So this is a recording for the Chapter 5 practice test and proctored exam, that you get an idea of what's expected of you as you're trying to prove these identities. So the problem numbers that you will see here are from the 7th edition of the Trigonometry book. I don't know if I have actually other editions on me. Anyway, 5th, 6th edition are allowed. And so the first one that I chose is number 64 from chapter 5.2, and you can see it there. So here, that's where it comes from. So the left-hand side, I'm going to write down. In fact, I have prepared this before, so there it is. So left-hand side, cosine A plus B over sine A cosine B. Now, basic identities and the Pythagorean should be memorized. Difference of squares, things like that. But other formulas that you find in chapter 5, the difference, the double angle, half angle formula, those kind of things, they're in the book for the practice test, and they're on the proctored exam itself, just in a different place that you can find them and use them. So in this particular case, as I'm trying to prove that the left side is the same as the right-hand side, well, first of all, I have to look up this sum formula here. So as I do that, I come up with this one. As I said, I have prepared that, and that's what you would be expected to type, and this isn't very difficult to type, right? So you don't have to try a fraction bar, those kind of things, or the theta or something like that. So anyway, so here's the sum formula, and so you look this up: cosine A plus B equals this one here. That's the numerator. So cosine A, cosine B minus sine A, sine B, check it out, that's true. And then I don't really have to do anything in the denominator just yet. So there it is. Okay, then I'm going to realize that as I divide the first term by the denominator, that the cosine B is going to divide out, and I have cosine A divided by sine A, and something similar is going to happen with the second term in the numerator. As I divide here, and notice that the sine A divides out, and I have sine B over cosine B, which I identify as tangent B right away. So the next line looks like this. So here's that minus tangent B, and then in front I have cosine A over sine A after the rest divided out. And this one here then would be 1 over tangent or cotangent. So as I write that down, type that on here, that's how it would look like. So cotangent A minus tangent B. And actually now we're done, because that's exactly what the right hand side says. So I'm going to copy that one in here. There we go. So right hand side says exactly that. I prepared this before you as I started out, that yeah, I can write it like this, but that's kind of like here as well. So either way, what I do, I have shown that it is indeed correct. So I'm going to say quod erat demonstrandum. I was able to show that that is the case indeed. All right, let's do a second problem. I'm not going to do this third problem here, by the way. So the second problem is this one. So sine squared theta over 2 equals cosecant theta minus cotangent theta divided by 2 times cosecant theta. All right, I'm not going to bother with writing theta. I'm just going to use x for this one. So this one is chapter 5.4. Number 45. So here's the left-hand side again. Type out. There we go. Okay, now I'm going to look up the half angle formula. So sine of x over 2. Again, I substituted the x for the theta because it's just easier to write. So if you forget about the square here, sine of x over 2 is plus minus the square root of 1 minus cosine divided by 2. But then, of course, it says, particularly here, square it. So here's that square. And, of course, as I square that, I get rid of the square root. And so my next line simply looks like this. There we go. Just that stuff right here. And, of course, again, going from here to here, I used one of the half-angular formulas, but I squared it, of course. Okay, now I'm going to look at the right-hand side. So the right-hand side, you see that fraction bar on the right over here. So cosecant, well, I'm going to use basic identities. Cosecant is 1 over sine, cotangent is 1 over tangent, or cosine over sine. And then cosecant is 1 over sine. So when I use those, I come up with this one, which looks pretty bad to begin with. Okay, and now what I can do is I notice that, and I just discussed this, that's what I was doing, that each one of these terms in the numerator and the denominator is divided by sine x. So just multiply everything by sine x. So this one simply becomes 1, this simply becomes cosine, and this simply becomes 2, which is exactly what I show you here that happened. So each term in the denominator and numerator, I just said that, got this 1 over sine x. So simply divide by 1 over sine x, or multiply by sine x each term. And you're allowed to do that because you do it both everywhere in the numerator and everywhere in the denominator. And that's how you get rid of it. And then we come up with that, which is what we figured out on the left-hand side. And so again, quod erat demonstrandum, done what I was able to prove. And again, this is kind of what you would have to type for these problems that you would find on the practice test and on the proctored exam for chapter 5. So it's kind of just use the keyboard as a typewriter. Don't try to do any kind of formulas. In fact, it might not even work. Please don't try. Just do this one here. Use it as a typewriter. All right, and that's it.